Hey guys, I told you I was going to go over one of these examples in the worksheet that I handed out, the Coulombs Law worksheet. So I randomly picked a question. Okay, I'm back. It's question number 4. So question number 4, I'm looking for the electric force. I wrote down the equation already because I know that's what I'm using. But I'm looking for the electric force of two charged particles. So I have particle 1. I'll say Q1 is equal to negative 2.0. 2.0 times 10 to the negative fourth coulombs. Remember, coulombs are really big, so often we have these very small scientific numbers. We have Q2, that was a positive 8.0. 8.0 times 10 to the negative fourth coulombs, and it was separated by a distance of 0.30 meters. So it's really just a plug and chug equation, just like we used to do with universal gravitation, where K that was given to you on the sheet, there are two ways we can do this. We can put K in at the very beginning, or we can put it at the end. I'm going to do it at the beginning. Now I wrote it on the side, but we can also put it in the numerator up here. So I can say that F is equal to 9.0 times 10 to the ninth. Now I know in our notes I said it's 8.99, but the number is 8.99 and 9 times 10 to the ninth. Our numbers are basically the same. Times negative 2.0 times 10 to the negative fourth times 8.0 times 10 to the negative fourth, all divided by 0.30 squared. Now, this is really all the meat and potatoes of our problem, just doing that whole thing. Now, bring that closer, so hopefully we can see it a little better. Now it's just calculator work. So I'm going to get up close and personal with the calculator. Again, I took the calculator that you guys should be using. And there are two ways to do it. First, I'm going to get real up close. Hopefully you can see, I don't know because I can't see the laptop, that this is in the math print mode. Now, if it's in math print mode, that means it's going to look like it looks in a textbook. So when I type in my number, I'm going to do the numerator first, parentheses, 9.0, then I press this times 10 button, times 10 to the ninth, and it's all up in the very top. We can see that, I hope. And scientific notation. In order to get out of that, I need to press the button to the side and then close my parenthesis so it's all the same size. If you don't do that, you end up with a syntax error. Remember, I don't like the math print mode, so I press the mode on my calculator. Then I go down to classic. I highlight classic. I press enter. And now, for me, this is easier. Now I'm going to do the same thing, parentheses, 9.00. I just press the times 10 to the ninth button, but now I'm not in that exponent form. Everything's on the same level, so I can just close my parentheses, and I can move right on with the numerator. Now, some of you may have also picked up the question asked for magnitude, and I have this negative here. Remember, magnitude means size, just the positive number. I want that negative, though, for the second part of the question. So I'm going to do everything on the numerator first. I have 9 times 10 to the ninth already, times negative 2 times 10 to the fourth. Now, when I'm saying times 10 to the negative fourth, and when I'm saying times, remember, I use parentheses for everything. I'm typing it in exactly how this is. Then parentheses, 8.0. And again, we don't need the point zeros. I'm just using them. Times 10 to the negative fourth. And now my numerator, I get negative 1440. So everything on the top came out to be negative 1440 divided by, I'm going to do the bottom squared, 0.30 squared. 0.3 squared is 0.09. And now I'm going to just do the numerator divided by the denominator. 1440. Notice I dropped the negative because I only want the magnitude. Essentially, I'm taking the absolute value, but that negative is important for the second part of my answer. So 1400 divided by 0.09 is a force of 16000 newtons. That is a massive force. Now, the question is the magnitude of the force, which is 16,000 newtons, and is it attractive or repulsive? Now, I know this is an attractive force for two reasons. Number one, the question said there's a positive and a negative thing, and I know opposites attract. Maybe I didn't know that, but I remember that when I do all my math, a negative answer means attractive, a positive answer means repulsive. So for part B, I know that it is an attractive force. So hopefully this example helps you out. If there are any other questions, by all means, drop a line. If you're having calculator problems, also drop a line. We can have a quick Zoom video conference or something like that if need be. That's it, folks. I hope everything's going as best we can. We'll get some new material coming to you shortly.